Welcome to Spring LIB.
In this problem, we have to use our knowledge of implicit differentiation and the inverse of, the derivatives of inverse trig functions to prove the derivative of a specific function that we're given. Now, this will make more sense once we go through the process. So we're told that y equals the inverse cosine of x. So what does that mean? That means the cosine of y equals x. That's just a property of the inverse trig functions. So we need to prove the derivative, and we have to use implicit differentiation. So we'll take the derivative of each side of this equation. So that means that the derivative of the cosine of y would be equal to the derivative of x. So what we do, we would get negative sine y times dy dx equals 1. Again, this part was chain rule, so we'd have this dy dx here. So then we can get dy dx by itself, because that's what we want. We want the derivative. So dy dx would be equal to negative 1 over the sine of y. Now we can do a substitution. The sine of y is something that we know. We can use the Pythagorean identity, the main trig identity that we know. So we can say that dy dx equals negative 1 over the square root of 1 minus the cosine squared of y. Now this is where it gets a little bit tricky. We defined what x was. We said that the cosine of y equals x. So we can do another substitution. Dy dx would be equal to negative 1 over the square root of 1 minus x squared. So then we can say that the derivative of the inverse cosine of x with respect to x is negative 1 over the square root of 1 minus x squared. And that was our goal. That's what the problem told us we needed to do. So I hope that this problem helped you understand a little bit more about implicit differentiation, and also I hope this built your intuition of the differentiation rules of inverse trig functions.